Hello everyone. This video is going to be the first in a three-part series, my first three-part series or multi-part video series. We're going to talk about using barycentric coordinates to develop a teleportation system that is robust enough to not have to worry about having particular points that you can teleport to. I will say that this kind of concept and solution to like how would you do a teleportation system is not going to be the right solution if you are looking to just say the player looks somewhere and you want to teleport them to where they look. That would be a straightforward line trace. If you have a machine the player walks into and then they walk out somewhere else, this is another, again, this would be far too robust of a solution for that. You don't want to do this with this kind of a solution for that. This is more of a solution for, let's say you see like you have a map on the wall, or you have like some kind of a defined region and you want, like let's say that you have a bunch of cows or sheep out in the field and you want to beam them all up to your spaceship, and your room is like a lot smaller and slightly different orientation, and you want them all to show up still relative to where they were on the ground, rather than just spawning them randomly throughout the room, or spawning them such that they all like popped in the center and then exploded outward. So this would be a way to do that. I will say that this first video is just going to cover concept. Our second video is going to cover the library functions we're going to make, that we're going to use to convert from points into our UVW, our barycentric coordinates, and then the implementation video will be the third video, where we're actually making ourselves blueprints and blueprint communication to utilize our library functions and realize the teleportation system. All right, so as far as a brief, quick overview then of barycentric coordinates for this video, I will link this page if you're kind of more curious about it. But there's a lot of math here that I just kind of want to touch on a couple important things to us, because I don't want to go over and explain all of this. This is a real video, not a math video. So some important things for us is that the coordinates UV and W that we'll be producing are considered to be unitless and are scale invariant and rotationally invariant, meaning that we don't need to have, like, if we have this particular shape for our teleport like pad, for example, this does not need to be the shape at all for the teleport pad on the receiving end. It doesn't need to be the same size. You could have this on the wall, and you could have another one on the floor. So you could use this kind of as a base kind of way to start making a portal mechanic if you wanted it to go that direction. And I mean like from the game Portal. Another important thing for us is our teleportation only works so long as we're inside of the triangle. If you're inside of the triangle, the barycentric coordinates UV and W will add up to 1. Outside, not true, and you're going to get some really wonky results. So this is particularly valuable to us for only like a region inside of this triangle. All right. And all right, I'm going to probably wrap up this video there then, and then the next video, what we are going to do is we're going to end up jumping into making our library functions.